Hey everybody, welcome back. It's the 25th of October and I'm solving LeetCode 2133, remove subfolders from the file system. This question, let's just see what it says. I'll explain what I did related to this question. I was stuck on it for a little while, uh, but then I clicked on this button right here. LeetCode provides every user with this, and it just says what topic the question is from. So I could see uh, this was something related with a tree and DFS. So that is where I based off my first solution, but then uh, I looked at a hint as well later on, and then I figured out a different solution for this, which I felt was much easier than to implement a tree. As you know, in Java, you don't get a tree. What do you call it? A tree data structure built in. So you have to build one on by your own. And I really wanted to avoid doing that because it would take a lot of time. But anyways, let's get into the question and then I'll explain both of my approaches and then we'll get right into the code. Uh, Given a list of folder, return the folders after removing all subfolders in those folders. You may return the answer in any order. If a folder is located within another folder, it is called a subfolder of it. A subfolder of folder must start with folder followed by a slash. For example, a slash b is a subfolder of slash a, but slash b is not a subfolder of this. The format of the path is one or more concatenated strings of the form this, followed by one or more lowercase English letters. All right. For example, LeetCode and LeetCode problems are valid paths, while an empty string is not. Okay. Let me just pull out my iPad now, and we'll look at exactly how this example is solved, and we'll see what do they mean by subfolders and what exactly do they expect from us in the output. All right, let me just do this really quick. So if we just look, I'll just copy down the first example that we have here. Uh, it says the folder. Uh, hmm, just a second. Yep. So we have something called as a folder. This is an array, and it has the elements which are slash a. We've got something as slash a slash b, and we have slash c slash d, and oops, I'm running out of space. It's fine. I'll just write it below. Slash c, d, and e, and then slash c slash f. This is our array. If you look at the output for this, the output would just be slash a, comma, slash c slash d, and then slash c slash f. I'm sorry, I should have done this before. It takes a while to draw all of it, but that's fine. All right, so how do we get from here to this output here? So if you look at it, we have something called as a folder slash a. And then right after that, we see something called as a folder slash a slash b. Now what the question wants you to do is, if a folder such as slash a already exists, if there's any nested folders inside in other elements, we are supposed to remove them. So in this case, you would not print slash a slash b. When we come to slash c slash d, we see that we just have a folder with an A. We don't have anything with the folder C and D. So we create slash C slash D, and this would be one of our input. So that would be reflected in our output here. Uh, Now, if you look at slash C D E, you can see that slash C D exists, and we have an E after it, and this makes E a subfolder of this folder. And as per the question, we are not supposed to insert it or into our output array. So we would get rid of it. Now, uh, we have this. Yeah. And now if you look at C/F, we see that there's a folder with /C, but not /F. And we are taking this as one. You can consider if you insert the whole thing here, just consider this as your root, as your mm, root folder. So you could equivalently call it as something like /example. And then if you look at /C/F, it does not match with the example output because the example says /C and D, and this is /C and F. So it doesn't exist. So you would enter this into your output here. And this is what you're supposed to print out at the end. All right. So now for the first solution, this is what I understood when I drew the tree, and I felt like this was the right answer for it. Let me go ahead and just, okay, that's A and B /A/B. Yeah. So if you don't know how a tree works, there's a visualization tool online, I think by University of San Diego, and you can just look at that and see how a tree is made. I'm just going to draw it really quickly here. So if you just look at the input, the tree would look something like this. And what we would do is we see, okay, slash is our main directory. And then you would go here and here. I mean, there's just one here for now. You would do this and you would insert an A, and then you would mark this value as 1. This just means that this is one of our root directories. Now we have an A and B. So if you were to follow the path for A and B, it would be like this, and then you would create a node with B. But since we reach A and we see the value 1, we don't go any further, and we say that, okay, since we have already discovered 1, this just means that /A and B is a subfolder of /A. So we don't insert it to our answer. So at the end of the day, we would just still be remaining with this tree right here. Oops. 1. Yeah. Then you would come again and you would look at C and D. To C, you would create the folder here and then another node here with D. So that insertion is done. We now look at C, D, and E. So we see that, oh, by the way, you have to mark the last node here as 1. So this whole thing becomes your root. And now when we insert C, D, E, we go this way. So we go to C, we go to D, and then we would insert a E over here. But since we see that at D we have 1, this just means that CDE is a subfolder of CD. So we would not insert this into our answer. And then finally, we have C and F. So you go ahead, you go to C, you see that there's not a 1 here. So we would continue inserting, and then we would add another node F here and then mark this as 1. And this answer would then be appended into our final array. So at the end, you would end up with, if you traverse this tree in a DFS sort of way, you would get /A as one of your output, then you would go back, you would go to C, and then you would go to D. So you would insert /C/D, and then you would come back and then insert /C/F, and that would be your answer. This is our final array. All right. Coding, that is a little bit difficult. I mean, it's easy, but it's just time consuming. There's a better way to do this. If you look at all these numbers, I mean, all these elements, uh, you notice that these can be arranged in these are arranged in a lexicographical order. I mean, they're sorted in a lexicographical order, and this makes a question easier. All right. For the second solution, if we sort the whole input array lexicographically, you would get this as your input array. And now we can see how we can form an answer from this. So you can see that what you would do is if your answer array is empty, you would insert um, the first directory right inside your answer array. So you would get an A here. I'm not adding the slashes because it is easier for me to just speak to you if I don't say slash A slash B, whatever. So I'm just inserting A here. Next, when we come to AB, you just check, okay, AB, is there uh, is there an element inside my answer array that is of length minus one of what I currently have? And is it matching the signature of my current input element? So I see that if I remove one element from this element, I would get an A, and I already have something in my answer array with the length with the same signature as my input. So I see that these two match, so I will not insert this element into my answer array, and I will go on and move on to the next element. Next, I see there's a C and D. Again, you just subtract one length from it, you get a C. You see, okay, I just have an A here. I match. Okay, do these guys match? No, it doesn't match. So I would insert this whole element into my answer array. And then we go ahead with C, D, and E. You subtract one from it and you get a C, D. You check with the answer array. Do these guys have the same signature? Yes, they do. So I will not be inserting this element into my answer array. All right. And then I go ahead with C and F. So I look at C and F, I subtract one from it, I get just a C. And I see that there's no reference with A, no signature matching with the letter C. So I would insert the whole thing into my answer array. And this is what would be my final answer. Obviously, we would have to append our slashes in the right places. And this is where we would get the correct answer. So let me just code this now. Let me get rid of my iPad. All right, let's get right into the code. So we need to return a list, right? So I would create this, call it uh, add list of strings. All right, and then what do I need to do? I need to sort these. So arrays.sort, I would sort the folder. All right, and then what next? I need to see if yeah, if it's empty, I would, okay, all right. So for uh, string fold in folders, I would do the following operations. I would check if array dot size is equal to 0, or if if fold dot starts with uh, array dot get uh, array dot size minus 1 plus the uh, plus the slash. If this is not true, if this is not true, then I would insert this into my array. So array.add, and then I would add fold. And then I would just return add. And I think this is right. So let's see, if the array was empty, we would just append whatever we had to it. we would check if fold dot starts with array dot get of length minus 1 plus with the slash. If this does not exist, if it existed, we would just skip over it. But if it does exist, we would add it to our array. And then we would just return our array. All right, let me try running this. Hopefully this is right. I think it is right. Folders. Okay, it's folder. Hmm. Yep. Let me try submitting it. And there we go. All right. 42 ms. I think this, oh, it wasn't bad at all. I think if the inputs were larger, the tree method would have been way better than what we're doing now. But I mean, this is good enough. All right. Thanks for watching, guys.